Assalamualaikum students. Today I am going to discuss about the A2 very important topic, alternating current. And in this topic, basically what we are going to discuss the properties of alternating current and some sort of rectification process. So here in this first half, I'm going to tell you about the comparison of alternating current with direct current. So that is why I have started with the topic with direct current, although this is not my main topic, but for comparison I need it. Direct current is that current which has a single polarity. This is the most important point for any direct current. It can have positive or negative, but it will have a single polarity, and its magnitude is variable, or it can have steady magnitude. It does not matter, but polarity must be single. That is the property of an alternating current. Then here I have shown you some of the alternating currents, or some of the some of the direct currents, right, which are not ideal, all of them. But in ideal direct current, it must be smooth, steady, and with single polarity. So out of these three, this is not the this is not the ideal direct current. The second one is the ideal direct current. Third one is the ideal direct current. Third one is not the ideal direct current. So that is steady and single polarity and smooth ideal direct current. Now I will talk about the mean direct current. So when we talk about mean direct current, it means that if I take the several positions where the current is, let's say here I have stated that there is 10 ampere current flowing through any resistor which has a resistance of 100k throughout the time, over the time. Then if you take average of all these points, what will you say, or what will you see, that the average direct current is 10 amperes. Now I will talk about the same situation in terms of power. So if you see that the average power dissipation of your direct current can be calculated how? Let's say, what is the simple formula for the direct for the power is I square into R. So the current is 10 ampere, resistor is 100 ohm. So the total resistance, total power dissipation due to a direct current in a resistor, that equals to 10 kilowatt, yani 10,000 watt. So it means that as the behavior of all direct current is steady and smooth, the same goes with the pattern of your direct power. So here I have taken the average or mean power dissipation due to a smooth DC, a direct current of 10 ampere passing through a 100 ohm resistor, that is 100,000 watt. I selected this value for a reference. I will use it at the end of the lecture again. So guys, stay tuned with me and watch this video till the end, so that you will be very clear about the comparison of alternating and direct current. So right after this, I am going to switch you people towards alternating current. In alternating current, there are some simple points to notice, or some simple properties of alternating current. First, it is produced by alternating generator. Second, that alternating generator has a rotation like 360 hertz, that is 360 degrees. That is why the alternating current has its variable magnitude, and because the coil rotates by 180 degree, and from 0 to 180 and 180 to 360. So that is why it has reversible polarity. So this is the main parameter. If the current varies or reverses its polarity, then that current is categorized as direct alternating current. So that is why the magnitude of the alternating current, peak magnitude of the alternating current, what we have in our daily life, in some of the countries, that is 220 to 240 volts. This symbol is for AC, and the frequency is 50 hertz. So that means that if I show you the profile picture of an alternating current, so did you see on my screen that it has magnitude and frequency, both. In some of the countries it is 110 volts and 60 hertz frequency. So overall, after all these properties studies, I can make a profile of the alternating current, that it has a reversible polarity and a variable magnitude. So this is my alternating current wave shape, which is basically the variation of alternating current with time or over time, or variation of alternating voltages over time. So did you notice it is 0, maximum positive, 0, maximum negative, again 0 for one cycle. For half of the time it is positive, and for rest half of the time it is negative. So that is a periodic variation. So I will talk about some properties of the alternating current, then I will discuss what is its frequency and how we can figure out the frequency of this. Now here we go. On this slide I am showing you that there are main properties which I have shown you there. One of them is the peak alternating current or peak alternating voltages. Actually, peak alternating voltages are the highest voltages of the alternating current or alternating voltages during any cycle. It is highest positive as well, and it is highest negative as well. Both are available in one cycle. So that is why for the highest value of positive current, we take I naught positive for the positive maximum and I naught negative for the negative maximum. As I have shown you here in my slide, this is the positive maximum and this is the negative maximum. So I will show you another figure, then it will be very clear to you. Now, second property is the frequency of the alternating current. So guys, when we talk about frequency of the alternating current, here in different countries, the frequency is stated as 50 hertz. So it means that the periodicity of this alternating current is 20 millisecond. I have calculated that how I reduce the periodicity by this frequency value. So I came to now that if the time period is 1 upon frequency, so 1 upon 50, it means 0.02 seconds, which shows me 20 milliseconds. So what is the frequency of the alternating current? It is 20 milliseconds. So guys, just see that if I show all these properties of the alternating current on the slide or on the graph, I will show you here. This is the y-axis and time is in millisecond along x-axis. So on time, 5, 10, 15, 20, 25, 30, 35, 40. So I have stated almost the time of 2 cycles, and here the value starts from 0, it reaches to maximum positive, then goes back to 0, negative maximum, goes back to 0, and this setup remains for complete cycle. I have shown you 2 cycles. So here this is the peak value which appears after 5 milliseconds, then the negative peak appears after 15 milliseconds, then positive peak appears again after 25 milliseconds and 35 milliseconds, and so on. So this tells me a little bit sinusoidal behavior. So that is why guys, I have stated one equation for you, and that equation of the current is represented by a sinusoidal equation or sine equation. I is equals to I naught sine omega t, or I is equals to I naught sine 2 pi by t into t, because 2 pi by capital T is omega, or you can say I is equals to I naught sine 2 pi ft. So this is 2 pi ft. So these all equations are basically the representative equations of your time, alternating current over time. In the same way, if you have alternating voltages, both all these three equations are here to represent it. V is equals to V naught sine omega t, V is equals to V naught sine 2 pi by t, and V is equals to V naught sine 2 pi ft. So remember this thing, that in your past paper this is a question which is asked to you. This is a short question that you will be given a equation with some numerical values, and you will be asked, okay, deduce the maximum peak amplitude as well as the frequency of the alternating current. So I have given you an example, two examples here. This is an equation in which I have given you the equation I is equals to 10 sine pi by 10. 10 is basically 10 milli into t. So when I compare this equation with general equation, that is I is equals to I naught sine omega t. So that means, okay, let me write here for you. That equation was basically, what was the general equation? That was I is equals to I naught sine omega t, or I can say it is I naught sine 2 pi ft. So it means instead of this 10, I have I naught. So I naught is equals to 10 ampere. So this is the amplitude, maximum amplitude. Now instead of this 10 pi t by 10 milli, pi into t divided by 10 milli, I have 2 pi ft in the general equation. So here time and time will be gone, pi and pi will be gone, and you will get 1 upon 10 milli is equals to frequency, and 1 upon 10 milli means the frequency is 50 hertz. So I got this equation, I got the frequency and amplitude. Now I have another equation for voltages. If you have the V is equals to 228 sine 34 pi t, at that time here the peak value of the voltage is 228 volts AC, and for frequency 34 pi t equals to 2 pi ft. Actually 34 pi t represents 2 pi ft, so that is why I got the frequency equals to 17 hertz. So this is basically second property. Now I will be talking about the mean alternating current, and then I will be talking about mean alternating power. Mean alternating current can be calculated as, at this instant the alternating current is 0. After 5 millisecond it is positive 10. After 10 millisecond it is 0. After 15 millisecond it is negative 0. And after 20 millisecond it is 0. So if I take average of all these points, I get 0. So this is again an past paper question. State, it means you have to memorize it. State the value of mean alternating current. So that means it will be 0. You will write 0. So here I have written that the alternating mean value of the alternating current during any cycle, during any number of cycles, that is equals to 0. Now I'm trying to make you clear about the alternating power, average power dissipation in a resistor due to an alternating current. Now in the previous example, what I have stated for direct current, I told you that keep that in your mind. Here I'm applying a 10 ampere current, but this 10 ampere current is actually not the smooth current. This is peak 10 ampere. Yani this current would vary. This current will vary. It will be 0. Then its peak value will be positive 10. Then it will be 0. Then its peak value will be negative 10. Then it will be 0, and so on. So that is why I plug in all these values in one of my table. That time in milliseconds, current, peak current, and yani current at that time, and sorry, this time is in milliseconds, right? And the current is in amperes and power is in watts. So here we go, guys. At time t is equals to 0, if I show you the wave shape as well, just see this wave shape. At time t is equals to 0, time t is equals to 0, current is 0, so power is 0, because power is again V I square R. At time t is equals to 5 millisecond, did you notice that current is 10 ampere positive? So when you multiply that, when you plug it in I square R, what is the power dissipation across this resistor? That is your 10,000 watt. Then after 10 millisecond, again 0, just see that. Then after 15 millisecond, current is negative 10 ampere, but when you plug it in I square R, here I have mentioned, then the power is again 10,000 watt. So that power went here 10,000 watt. Then after 20 millisecond, the current is 0 and 0. So that is why if I calculate the average power or mean power dissipation in an identical resistor due to alternating current, then it is how? It is 0 I square, positive I square R plus 0 plus negative I square R divided by 4. So this is basically I square R divided by 2. So I can simply state this concept that the power dissipation, average power dissipation in any of the resistor due to an alternating current is equals to its peak power dissipation, the highest power dissipation, divided by 2. Is it clear? Now, here is the last phase of this topic, that I have plugged in the values, that the alternating current has this variation, where alternating power, this is again a past paper question. You people are asked to sketch a graph of alternating power, not the alternating current. So here we go, the alternating power graph. As you see, the power at time t is equal to 0 was 0. I have shown you in the table. This is the table, this is the current, this is the graph. After 5 millisecond, the power was 10k. I have plotted it at 10k, then 0, then again positive 10k, then 0, and so on. So when I took average, I came to know that the power dissipation due to an alternating current is equals to 5000 watt, where the power dissipation due to the same amount of direct current was equals to 10,000 watt. So here is this sketching of the graph should be very focused by you people. Once you people will focus this graph, it would be quite clear to everyone that how to draw. This is 3 marks question, so I believe that you people can easily score these 3 marks, that you can sketch the variation in the power. Now the last conclusion of my today's lecture, that in any identical resistor, which I have shown you in the previous slide here, this was a 100 ohm resistor for alternating current, and this was a 100 ohm resistor for a direct current. Here this was the 100 ohm resistor for direct current, 10 ampere DC, and here we go 10 ampere AC. 10 ampere AC means once in a cycle its value reaches to positive 10, and once in a cycle its value reaches to negative 10. So guys, the last conclusion, that in any identical resistor, the mean power dissipation due to an alternating current is always half of the mean power dissipation due to an identical direct current in the resistor. Yani, if I just figure out this value for 10 ampere DC direct current flowing in a 100 ohm resistor, the average or mean power dissipation was 10,000 watt. But for same 10 ampere alternating current flowing through a 100 ohm resistor, the mean alternating power dissipation was 5000 watt, which is exactly half of your power dissipation due to direct current. So that was all what I had to discuss with you guys. I hope that this video will help you out. to build up your concept of alternating current. For all these type of videos, the conceptual videos, stay tuned in my channel Fizzbridge. And for online classes, you people can contact me in the given link and at the contact number. And in the next lecture, inshallah, I will talk about the most horrible topic of this alternating current, that is the IRMS and the conversion of I peak and IRMS, and from IRMS to I peak. And secondly, the conversion of alternating current into direct current. I will talk about rectification in detail. So hope you people will watch that video with me. Thank you.